Chapter 7, Statistic, Section 7.1, Estimating Parameters and Determining Sample Size. What I did for Chapter 7, I summarized all the sections and the formula in one page. So for Section 7.1, we are using the formula for proportions. For Section 7.2, we are using formula for the mean. And then for Section 7.3, Section 7.3 is for standard deviations. So this is a summary of all the formula that you need to know for that sections. So the first one is proportion of populations. Basically what we do in this section is, let's say you want to calculate proportion of male to female in one particular city. So what we do is, rather than going through the entire population, we take a sample, and when we take a sample, which is the n, the value of n, then we indicate, for instance, if the sample indicate that proportion of male to female is 40%, then we say proportion of population is 40%. That's the proportion of the sample with a hat. P hat means proportion of sample plus the margin of error. So for instance, we say, okay, proportion of population is 45% plus or minus 2%. That the plus or minus is the margin of error. Or let's say if you want to calculate proportion of mean of populations, which this is a simple for population, then you take a sample and you calculate mean of the sample, then plus or minus margin of error. Let's say I get a job in one company, and for that particular position, person human resources tell me that the salary for this position is $50,000 plus or minus 5,000. That means people are within that range. So that the plus or minus is the margin of the error. And to calculate the margin of error, this is the formula. Now, point estimate. The sample proportion that we are using p hat is the best point estimate or single value estimate of the population proportion of p. So again, for proportion of population of capital P, if you take a sample and calculate the proportion of the sample, we show the p hat, and they call it point estimate. Confidence interval, and then the sample size, which is n. I want to discuss that. So here, the point estimate is the single value used to estimate population parameters. Confidence interval or interval estimate is the range or an interval of value used to estimate the true value of population parameters. Confidence interval is sometimes abbreviated as CI. Confidence level is probability of 1 minus alpha. They call it degree of the confidence. And for some of the numbers that are very popular, we already have it here. For instance, is most common confidence level, if the confidence level is 90% or 0.90, the alpha corresponding value would be 0.10 and so on. Now, what is the confidence interval? We must be careful to interpret confidence interval correctly. There is a correct interpretation and many different and creative incorrect interpretation of confidence interval. If you say the proportion are between these two numbers, what does that mean when you say proportion of population are between these two numbers? It's correct to say we are 95% confident that the interval from 0.828 to 0.872 actually contain the true value of the population proportions. It's wrong to say there is 95% chance that the true value of P will fall. This is wrong. Or say 95% of sample proportion will fall between. These are the wrong statement. So if you are taking so many samples, and you understand out of these samples, there are 20 intervals, 19 out of these 20 contain the actual population proportion. There's just one that doesn't. Confidence interval obtained from this research center pool does not contain the population proportion because P is 90% is not between that. So let's say we already know what the actual population is, and when you take so many samples, there is one sample that doesn't have number for proportion of population, but 95 or 90%, 90% would have that. 95% would have this 0.93. This is confidence of 95%. All right. Now, we had this example in the past. This is exaggerated that we had in the screed that a couple want to have 20 children. What's the probability of none of the child is out of 20 is a girl? 0. One of the probability, just 1 out of 20 is a girl. 0, 2, 0, 3. So you see, as the number of girls increase, the probability also increase. There is a place that probability, if it falls below that, is critical. Means for a couple to have 4 girls out of 20 is very, very unusual. Or for a couple to have more than 14 girls out of 20 is very, very unusual. So what we need to do, we need to specify these 2 points. Means any number greater than 14.4, which let's say greater than 15 girls out of 20 is unusual. If you say a couple have 20 children, 15 or 16 or 17, 18 out of 20 are girls is unusual. Or if you say a couple have 20 children and 4 and less are girls is also very unusual. So these 2 are the critical zone. And alpha is the area of these 2. The total area of these 2 shaded area is alpha. So half of this is alpha 2. This area is alpha divided by 2. This is alpha divided by 2. When you determine these 2 z value, these 2 z value show the border points. That's why we should say z of alpha half. Means this z is for calculation of the half of alpha. Like on this example, see, these are the critical area. So what is area? The area of this alpha half. What is this area? Alpha half. So the alpha, which is the total area, is given in the problems. If you take that and divide by 2, then you calculate area of each tail. There are 2 tails, and area of each is half of the alpha. And this is a better picture of the histogram. Now, if alpha is given in the problems, confidence level is 95%. So what we do is the total area under each curve. Total curve under each curve is 100% or 1. So if the confidence level is 95% or 0.95, how do I calculate these 2 areas? How do I calculate these 2 areas? You subtract 95% or 0.95 from 1, that give you 0.05, which is alpha. What is half of this for each area? Half of alpha is 0.05 divided by 2, or 0.025. And we need this area, the red one, for our calculation to find the z. So if the area is 0.025, the z value is 1.96. There are some of them that are very common that normally we have it here. So we are saying if you have 95% confidence level, then the alpha normally is 0.05. And if you go to the table or calculator, that would give you the z value of 1.96. The one on this side is minus 1.96. The one on the right is positive 1.96, because the 0 is in the middle. And as you go to the right, if numbers are positive, you go to the left, number are negative. These are some examples. What is a 95.95? We subtract from 1, divide by 2. Area of each tail is 0.025. So if you want to use the table A2, you just go and find that area. That area is for here. When you find the area, then z is minus 1.96. That's how you find the z value. Or for instance, on this one, this is 90% confidence interval. So if I subtract 0.9 from 1 is 0.1. 0.1 is the alpha. Half of that is 0.05, means area of each tail, the red ones, is 0.05. This is the area of 0.05. So you go to the table and you find that numbers. You find the number which is 0.05 is somewhere between here. So what is the z? The z is 1.6 and 4 here between. So it would be minus 1.64 and 1.64. And for 0.98, the same way, and 0.99. Now, it's easier to use the calculator to have the exact number. For instance, if I want to find this number using the calculator, you go to the second verse. For the z, you go to inverse norm. As for the area, what area do I have? The area of each tail, not the alpha. I need alpha half. Is 0.025. 0.025. For this area, we want to know what the z is, right? So you just scroll down to paste. Okay, let me clear this. I'm sorry. That gives you minus 1.96. And you understand the one on the left is minus, the one on the right is equal with a positive. So that's how we find the z value if you already know the tail area. So you don't have to go to the table because you are using the calculator. In this problem, they ask the p hat proportion of the sample is given, n value is given, is a 95% confidence level. They want us to calculate the E and proportion of the population. So for that examples, these values are given, n P hat, Q hat is always 1 minus P hat, so we don't have to give you both. If we give you P hat, you could subtract from 1 to find Q hat. The formula for margin of error is this. We already have the Z of alpha half. Again, that means for this area is alpha half. So Z of that would be, they call it Z of alpha half, minus 1.96. It doesn't matter whether you put a positive or negative here. P hat, Q hat, and you have all the numbers that give you the margin of error. So proportion of population is always between these two, means it's P hat plus margin of error and P hat minus. So if you input these numbers, that's what you get. Now, if you want to use the calculator can calculate the proportion for you, but it requires the X value. We don't have the X value, we have P hat, but we know the formula is P hat is X over N. P hat is X over N. So if I cross multiply, X is N times P hat. You always round it up because you want to have the whole number. Calculator doesn't understand the decimal. Round it up, 640. Then, if you want to use the calculator to, instead of going through all this, you could just go ahead and put 1. Stat test, then screw down to 1 proportion Z interval, which is A. X is 640. N is 1487. Confidence level is 0.95 or 95%. That gives you, what you see in the parentheses is P plus E and P minus E, which are these two numbers, see? So that's how we use the calculator to find the proportion. And that is very handy to do the rest of the problems here. Now, when we ask you to find the number of samples, samples, it has to be done by hand calculation. It's not programmed in the computer, in the calculator. If the value of P hat and Q hat are given, you just use it. But if the P hat or proportion of the sample is not given in the problems, always assume 50% or 0.5. So again, in case P hat or proportion of the sample is unknown in the problem, is not given, if P hat is not given, then you use 50 for each. If you multiply 0.5 times 0.5, see, if P hat and Q hat both are 50%, so that means you take 0.5 and multiply by 0.5, that give you 0.25. That's why you have 0.25 here. It already calculated P hat times Q hat. So you use the formula in case, you use this formula in case P hat is not given in the problem. This is an example of how to find the sample size. Z is given. You have to raise it to power of 2. P hat is 0.8, Q hat is 0.2. Margin of error is given in the problem. E is 0.03, so it has to be in the decimal here. Sometimes they say 3%, but you have to convert it to the decimal in order to put it here in this formula. So that gives you 682.951. We want this to be whole numbers, so you round it up to 683. Here they're saying if p hat is not given, then use this formula 0.25, which is 50% times 50%. That would give you that number. In case you are using one of these three, this is the options. Another example is for this one, Mendelian genetic. In this one, there are 580 Ps. 420 of them are green and 152 is yellow, 99% confidence. Interest of percentage of green Ps, they ask us to do that. So out of 580 Ps, 420 are green, 152 is yellow. Find the percentage of the green. P hat is X over N. Percentage of the green is 428 out of 580. That 0.74. Q hat is always 1 minus that. Now, is 99%. For the 99%, again, you could use second Var's inverse norm. Area is 0.05. Why? Because if you take 0.99, the confidence level here, if you subtract 101, give you 0.01. Remember, 0.01 is the alpha. We need half of that. So half of that, it would be area of each term. Then if you want to find a z, you go to the second Var's inverse norm and find z this way. And then place it in this formula. When you find the E, P hat plus E and P hat minus. And again, if you use the calculator, if we just ask you to find a proportional population interval for populations, if you don't specify in the problem that we need margin, then you could use your calculator and with this calculation find the proportion of population. And this is how to use. There are again some numbers that are very common, so you could also find it at the bottom of this table. Like here, you know how we say for 0.99, Z is 2.575 or almost 2.6. See, this is 2.575 for 90%. That's just, some of the confidence level that are very common and used all the time is given in here. But, or you could just go ahead and find it through the table. But again, it depends. If you use a calculator, you don't even need to do that. This is another problem talking about how to calculate the sample size. And they want you to find P hat and Q hat and 99% confidence. Very similar. For 99%, you already know the value of the Z. P hat and Q hat, if it's not given, you assume. So it would be what, 0.25 this part? Margin of error is given in the problem. It's at 3%. It has to be in the decimal. It has to be decimal. So it would be 0.03 to power of 2. Part B, they give you the P hat is given. So Q hat is 1 minus that, and you put that in the formula. These problems are all very similar to the same format. Now, for the homework, again, we start the homework by using all these formulas. See, this is the formula how to calculate the sample size. This is a E. P hat is always X over N. Q hat is 1 minus B. And this is how to find the interval for proportions. These are the keys for the Problem number 2. Number 3, they just want you to find z of alpha half, 97%. I'll show it to you. I use the calculator. See, this area is 0.97. So that means the remaining area is 0.03. Remember, 0.03 is the alpha. What is half of that? 0.15. So then if you know the area of 1/tails, you go to second inverse norm. But remember, always put area of 1/tail here. The second one, we understand that P is always P hat plus E, capital P. So that means these two numbers are P hat plus E and P hat minus E. So when you solve these two equations and two variables, that give you P hat and margin of error. Number 6, again, we find these are given in the problem. These are given numbers or percentage of confidence level. P hat is that. They call it also, P hat is called point estimate. How do you calculate the value of E? You need the Z, 0.99. We know we give you 0.258. You put that one here, or 0.2575. You find the E, you plug it into this equation. Or you could use the calculator, and that give you the interval. So we don't really need to use these tables that is given in the problems. Again, these problems, 7 and 8. They all are very similar. So if you want to use a calculator, you just need this information. Remember, if you want to use a calculator needs the x value. If the p hat is given in the problems and you know the n, but you don't know what the x is, you could cross multiply here. X is p hat times n, and you could round it up to a whole number and then use that number along with the other information to find your proportion of population. All right, so the rest of these are all very similar, and then would be like a multiple choice. And the solution of all would be at the end here.